Have you ever wondered how we measure atoms, those tiny particles that are too small to see or feel? That's where the mysterious mole comes into play. It might sound like a furry creature that lives underground, but in the realm of chemistry, a mole is something entirely different. Imagine you're shopping for apples. You wouldn't ask for 6.022 times 10 to the power of 23 apples, would you? No, you'd probably ask for a dozen. A dozen is a unit that represents 12 items. Similarly, in chemistry, a mole is a unit of measurement. But instead of representing 12 items like a dozen, a mole represents a staggeringly larger number, 6.022 times 10 to the power of 23 items. Now that's a number so large, it's almost impossible to visualize. It's like trying to count the number of grains of sand in the entire world and then multiply that by 1 billion. But why do we need such a large unit in chemistry? That's because atoms and molecules, the building blocks of everything around us, are incredibly tiny. We're talking about objects so small that even a speck of dust can contain billions and billions of them. So, to make it easier for us to work with these microscopic entities, we use the concept of the mole. It gives us a way to convert between the macroscopic world that we can see and touch and the microscopic world of atoms and molecules. When we say we have a mole of a substance, it means we have 6.022 times 10 to the power of 23 units of that substance. So whether we're talking about atoms, molecules, or ions, when we use the term mole, we're dealing with a unit that allows us to count these particles in a practical and manageable way. So when we talk about a mole, we're talking about a very large number of things. Why such a strange number for a mole? And who came up with it? Now, there's an intriguing question. This brings us to the heart of our discussion today. Avogadro's number. Now, Avogadro's number isn't just some random selection, it's a very specific quantity, and it's got a bit of a story to it. Avogadro's number, which is 6.022 times 10 to the 23rd power, is named after the Italian scientist Amedeo Avogadro. So why this number? Well, Avogadro's number represents the number of atoms in exactly 12 grams of carbon-12. But why carbon? Carbon was chosen because it's the basis for organic life and is found in all living things. Now you might be thinking, that's fine and dandy, but why do we need such a big number? I mean, 10 to the 23rd power, really? Well, atoms and molecules are incredibly tiny. They are so small that even a tiny speck of dust contains an astronomical number of them. So, to deal with such incredibly large numbers of atoms or molecules, we use Avogadro's number. But the real magic of Avogadro's number is not just in its size. This number allows chemists to count atoms by weighing them. Yes, you heard it right, by weighing them. This is incredibly useful because, let's face it, counting atoms one by one would be a bit of a nightmare. So, when chemists weigh out a sample of a substance, they can use Avogadro's number to figure out how many atoms or molecules they have. This is a fundamental principle that underpins much of chemistry and allows for precise measurements and calculations. In essence, Avogadro's number is a bridge. It's a bridge that connects the macroscopic world that we can see and touch with the microscopic world of atoms and molecules that we cannot. So thanks to Avogadro, we can measure atoms without needing to see them. It's quite remarkable, really, when you stop to think about it. But how does the concept of a mole apply to our everyday life, you may ask? Well, it's more ingrained in our daily lives than you might think. Take, for example, the pharmaceutical industry. When you pop a pill for a headache or any other ailment, have you ever wondered how each pill contains the exact same amount of active ingredient? This is where the mole concept comes into play. Pharmaceutical companies use the mole concept to precisely measure the amount of active ingredient that goes into each pill. This ensures that every pill you take has the same therapeutic effect, whether it's the first or the last one in the bottle. But it's not just the pharmaceutical industry. Food companies also use the mole concept to determine the nutritional content of their products. For instance, When you read the nutrition facts on the back of a cereal box, you'll see the amount of vitamins, protein, carbohydrates, and other nutrients listed. These measurements are determined using the mole concept. Food companies use it to accurately measure the amount of each nutrient that goes into their products, which is why you can trust that a single serving of your favorite cereal provides the nutrients it claims to. Even in the field of environmental science, the mole concept is used to measure the concentration of pollutants in our air and water. It helps scientists determine the severity of pollution and devise strategies to mitigate its impact. And let's not forget about chemistry. Whether it's the chemistry of baking a cake or the chemistry of creating fireworks, the mole concept is key. It allows us to predict the results of chemical reactions, making it possible to create the perfect cake or the most spectacular fireworks display. So as abstract as it may seem, the mole concept has very concrete applications in our daily lives. Whether it's ensuring the effectiveness of your medicine, determining the nutritional content of your food, measuring the severity of pollution, or predicting the results of a chemical reaction, the mole concept is there, working behind the scenes. Opening: how can you use the mole concept to make calculations? Well, let's dive right into it. First, we need to understand the idea of molar mass. Molar mass is simply the mass of 1 mole of a substance, usually expressed in grams. It's a bridge that connects the macroscopic world of grams and kilograms with the microscopic world of atoms and molecules. For instance, the molar mass of water, H2O, is about 18 grams per mole. That means if you have 1 mole of water, it would weigh roughly 18 grams. This might seem abstract, but it's a solid fact that helps us do some pretty neat calculations. So, how do we use this concept to convert between mass and moles? Let's consider an example. Suppose we have a sample of carbon with a mass of 12 grams. To find out the number of moles in this sample, we simply divide the mass of the sample by the molar mass of carbon. The molar mass of carbon is about 12 grams per mole. So 12 grams divided by 12 grams per mole gives us, drumroll please, 1 mole. But wait, there's more. We can also use the mole concept to calculate the number of atoms or molecules in a substance. Remember Avogadro's number from our previous discussion? That magical number, 6.02 times 10 to the 23rd power, tells us the number of particles in 1 mole. So if we know the number of moles, we can find the number of atoms or molecules by simply multiplying by Avogadro's number. To recap, molar mass is our bridge between the macroscopic and microscopic worlds, helping us convert between mass and moles. And with the mole concept and Avogadro's number, we can determine the number of atoms or molecules in a substance. Closing: with the mole concept, you hold the power to make some pretty impressive calculations. So, what have we learned about the mole? Well, we've embarked on a journey to understand the mole, haven't we? It's not the little creature that burrows underground, but a colossal concept in the realm of chemistry. The mole is a unit of measurement, just like a dozen is to eggs or a pair is to shoes. Only this time we're not counting eggs or shoes, we're counting atoms, molecules, electrons, and other minuscule particles. We've learned about Avogadro's number, a significant piece of the mole puzzle. Named after the Italian scientist Amedeo Avogadro, this number, approximately 6.02 times 10 to the 23rd power, defines the mole. It is the number of atoms in precisely 12 grams of carbon-12, the most common isotope of carbon. A mole of anything contains this many entities, whether it's atoms of helium, molecules of water, or electrons in a current. We've also discovered the mole's relevance in our day-to-day lives. It may seem like an abstract concept, but it has concrete applications. From calculating the amount of sugar needed to sweeten your morning coffee to determining the oxygen required for a hospital patient, the mole concept is everywhere. It's in the air we breathe, the food we eat, and the medicines we take. It's in the paint on our walls and the fuel in our cars. Our journey also took us through mole calculations. These are essential tools for chemists, allowing them to work out quantities in chemical reactions. By using the mole concept, chemists can predict the outcomes of reactions, create new compounds, and develop life-saving drugs. In conclusion, the mole is more than just a unit of measurement. It's a bridge between the macroscopic world we see and the microscopic world of atoms. It's a key that unlocks the door to understanding the universe at its most fundamental level. The mole might be a small creature, but in chemistry, it's a giant concept that helps us understand the microscopic world of atoms.